With OneFuse 1.2, we've got two new modules. We've got Ansible Tower as well as scripting. And Ansible Tower, basically what we're doing is we're allowing you to create Ansible Tower backed services with OneFuse. So the consumers of this API-based service don't really need to know anything about Tower or have direct permissions to Tower. The administrator in OneFuse can define a policy for how you want to provision a particular service and how you want to deprovision that. And when I say service, that consists of a set of job templates which map to Ansible playbooks, and you can organize those into provisioning and deprovisioning areas so that you can have a life cycle of something that you're producing with the service itself. So that allows you to define what it is that you want to be run, as well as where you want it to run on, and that can be derived from inputs that the user supplies in terms of where they want the configurations to execute, from a job template standpoint, or and then the limit of where that applies within the inventory and how to add it to inventory. So basically, full control over the major pieces of Tower that matter from a, where the control of how you want a service to be constructed, and making that simple to request and execute, and then plumb into upstream providers and tools through APIs. And provided, we have a provided VRA package that works on VRA 7 and VRA 8, as well as a Terraform provider, so you can easily insert Ansible Tower based services directly into those providers, or call from the API. You can proceed to the next one. So scripting is another popular one, and this is basically you can create any API-based service based on an existing script, and that script could do something as simple as depicted here, of just updating a particular service or installing patches on a box, or it could be more complex in that maybe you want to wrap a Terraform-based integration or provider. You want to wrap a Puppet module or an Ansible playbook. So it's basically limitless in terms of the possibilities. It's SSH based, so there's no agents required. You can execute the scripts on anything that can listen for SSH. So that's a PowerShell for Windows Server type content, or Bash, Perl, Python, etc. For Linux. And what we're able to do is basically execute that script in context of how you have it defined in the policy, and then return the results if anything's echoed out in the script that you want to persist in inventory. That those JSON-based outputs are going to be stored in inventory, so that you can see what was provisioned, and also go into OneFuse and track the inventory and have a life cycle for create destroy. So scripts are very powerful, very, very prevalent, but there's essentially no inherent policy or abstraction layer or ability to easily API enable those scripts and then plumb them into any provider or upstream tool. And that's what OneFuse brings with the scripting module. And if you give me control, I'll do a quick demo of this. All right. So with where I'm logged in here is OneFuse. This is the OneFuse user interface. You can see on the left-hand side, I've got several modules. On the right-hand side, the endpoints that I can use from those modules. I'm going to focus first on Ansible Tower. So with Ansible, you can create one or more policies that represent your service. So in this case, it's a pretty simple one. I'm just installing Apache. I've selected an existing endpoint that I'm installing it on, and I've defined a very simple, install HUV job template that I've defined in my Ansible Tower system. So keep in mind, this is a very static definition, but it is possible to use the template engine syntax to make this dynamic, so that if you did have a variable, you can actually dynamically reference that variable that you provide when you do the execution. So that puts the policy administrator in full control of whether or not they want to make decisions based on inputs, like if the environment is production or development, or if it's a specific application, and they can define one or more job templates. It's not just singular. So it's a set, and it's not just provisioning. It's also what do you want to do with deprovisioning. So as part of decomming this service, maybe I want to uninstall HTTPD or do something different like take a backup. In addition to that, we also do inventory management. So we can dynamically add it to one or more groups. Again, that can be also referencing variables with different options here. We can, with the way that you execute from a command line or from an API or from an upstream tool, you can target a specific host that you want to run it on, one or more hosts using Ansible Tower syntax. Or it can be ephemeral and just run the job template on its own without any attachment to inventory. So this is optional, but it allows you to essentially track the host that you're building within Ansible Tower itself and dynamically associate those to groups. And then from an overrides perspective, you can provide additional variables that you want to pass. All the template properties that are passed in when you execute get passed over to Ansible Tower as well. So real quickly, this is a result of a job run here. So you can see where we actually installed HTTPD. We can see what host it was a host that was being built from another provider. In this case, the source was CloudBolt CMP, but that could have easily been Terraform or VRA itself. And the host and the limit, so it only runs on that machine. And then if you look at the job details, you can see the API call that came in, the inputs that were passed, not too many in this case, and then the result that we gave back, and the log file that ensued. Who requested it, what source were they coming from, how long did it take? So I'll switch over to scripting, and then I'll show you VRA and Terraform briefly. So on the scripting side, there's a couple of scripts here. One is just creating an Active Directory user. So it's pretty simplistic, using PowerShell on Windows. So as part of the provisioning process, we want to basically use a PowerShell script that executes against and passes in parameters like first name and domain and things like that will be passed to this policy during provisioning. And then deprovisioning, we're going to clean that up and we're going to delete that specific username. So pretty straightforward. And if you want to see, what those deployments look like, we have some in the inventory here. So every time we're running it, so whether it's AD user or whether it's installing Apache, like in this case, if there's outputs from the script that get persisted, those will be persisted back in inventory. And again, a link to the job to see how it was called, from the API, any template parameters or properties that were passed into this particular policy run, and then the scripts and the outputs and the outcomes of that, and stored in inventory so that you can easily deprovision it. And then I'm going to show real quickly VRA as well as Terraform. So on the vRealize automation side, we've got some new features with an Easter egg for being able to drag in Canvas resources. So as I mentioned, scripting or DNS or anything else from one fuse, this is new. So being able to drag that directly into the Canvas, execute a script, or you could execute Ansible Tower policy in the same fashion outside of the context of a machine. Or within the machine, you can add properties that will execute during the life cycle of that machine. So while I'm building it, after I deploy it, I can actually invoke things with Ansible or with scripting and so forth. So this is new feature that we have within VRA 7, or sorry, VRA 8, and with VRA 7, it's standard lifecycle as well. And then for Terraform, I'm just going to show some configurations just to give you an idea of how to call it. So pretty simple with Terraform. Usually there's a lot of I guess, effort around defining the variables and making sure that you can declare everything that you want to be able to consume a service. With OneFuse, it's pretty straightforward. It's basically this stanza here is all I need to be able to reference or be able to invoke an Ansible Tower based deployment using OneFuse. And providing either variable references for limit and host of where I want to execute it on, as well as template properties, and that's about it. Same thing with scripting, very similar. I can either reference template property variables that I've defined in the vars files, variables files, or directly inject them here when I make a call. So OneFuse scripting, Tower, and then pretty much every other module is done in a very similar fashion. So making it easy to consume resources directly that OneFuse provisions directly within Terraform. Anything Terraform builds, OneFuse returns the outputs. Those are stored in the Terraform state. And then when you do a deprovision, Terraform will reclaim those resources and after they're deleted in OneFuse. Additionally, we do have the capability of referencing property sets, both in V-Ray and Terraform. So you can define them like this as a map, or you can reference groups of properties that are in the OneFuse user interface that you can define to centralize the logic between things like Terraform and V-Ray, and not necessarily have to hard code any of these things within the respective platforms or configurations. So a lot came out with the 1.2 release. We're excited to get this on the market. A lot of customers waiting on it. So if you're interested, do reach out and we can help get a trial set up and get you a POC going.